implement reader in one of these? Evaluate. Oh. Okay. Excuse me. So I think that this is actually correct, but I need to have the monad instance of reader, I think. So in this case, we don't, or in the above case, we don't actually need it, but I think we do need it here. So if reader is not a monad, I mean, we can't write the following. So let's fix that real quick. So instance, functor, reader. So I'm just gonna put this stub in here. Uh, Rab. Uh, all right. So does this fix the? No, it doesn't. I can figure out how to uh, get this to work, then, at least these stubs are just unimportant. But I guess I should motivate this that we're working on exercise exercise 10.1 from the Book of Monads. So like, let me just show some stuff here. So if we look at this A, what is this complaining about? I'm confused. Couldn't match type him with reader R. Right. So the more I'm thinking about this, the more I feel like we need to fmap R. So this should compile. So this needs to be a reader. So we need a function. What do these look like? So that kind of looks like pure. Here we need a reader. What's C though? Need that thing. So, okay. So if C is a monad, then we have a reader of but this doesn't compile. Right, like this doesn't work. Hmm. This is really tricky for me. So we need to compose a reader where this is that. So we need to take C. So let's do this. Dot here. Let's put this on the next line and that down there. Put a hole here. Right. So if we take C and then bind, we're gonna get RRA. And if we run reader RRA with R, we'll get an A, and then we need to just stick it in the other monad? Yes! Alright, there we go. We figured it out, so that wasn't that bad. It's just, I didn't know how to do this last time. I could not figure out how to do this last time, but I think it's because we're sort of taking Jappy's advice and just whenever we need a function, like you just create one. Kind of a trick, I guess. So I did something silly. I on the tags for this stream, I put composing. Do you think that's what they meant? Do you think that's what Twitch meant with the tag composing? I don't think so. It's not a very good joke, but it's a joke. Now, one question is, do we even need these instances to make this work? Because I don't think we do. No, we don't. All right, so yeah, I think this is exactly what we want. Neat. All right, so the other part of this is think about which converse operations do not exist in general. Excuse me. Which converse operations? Okay, so can we flip writer and M? Do we just start trying to write it, I guess? Um all right. So this time it seems to me like we're gonna have something similar to this. But I gotta remember just generally what writer looks like. It's just a tuple of AW. Okay. So C. All right, so we kind of have the same situation here. We need something like this, and then we're gonna have this. We can't. So this is gonna be like a writer A. This down here. Right? Oh, wrong one. Gotta get used to that. That's a writer A, which if we AW equals one writer AWA in uh Is, Cannot construct the infinite type. So like, by going this way, we're losing information about W. Right? Like, I can't. Although I'm not sure what this error means. Let's look at it in a slightly, like in GHCID. I just want to see if there's maybe more information here. Wait, found. Okay, found hole. M is rigid type variable bound by the type signature. Could it match type M with writer W? Expected type. Yeah, so in this case, writer has to be a monad. So but it has to be the same monad. According to this. And it won't be the same monad. It's going to be a different monad. So I think that's why this doesn't work. But let me just make sure that that's the case just by basically entering this, but replacing it with reader with writer. And see if it compiles. It shouldn't. Because for the same issue right here, we can only embed the same monad. We can't embed a different monad. So the outer monad in this case cannot change. And the only way to do this is by, I think you have to embed. I don't see how else you would do this. So why does it work down here? Because my function embeds in the same monad. The pure is outer. That's why. Okay. So that's the case. You need bind. You need bind. And the only way you can use bind is by embedding in the same monad. So that's why in each of these cases, the pure needs to end up on the outside. Okay, so let's write that. So the converse, or the complement to both of these functions are not possible to implement because bind works by unraveling or flattening an MMA. Just put ticks around here there. However, we need bind to create, reader or writer, whatever. Well, let's just write writer as the outer monad, which isn't possible. Okay, so I think that's the end of the chapter. Basically, there's some stuff in here about like there's an example of this for lists. Like you can actually write these swap functions, but it doesn't obey one of the monad laws. So anyway, so we're gonna work towards another exercise. And implement some more things, because that's what I like to do. Listed unlisted do. Sorry, I was like very confused at what they were writing down here. Okay, so this should fail because of applicative. So if I put in instance functor listed m zt. So a think that's the right implementation. Oh, except leave that off. Oh. So X here. Kind of want to write this not in do notation. So excess is a list of monads. So X is a monad. Could it match type M with empty list? All right, so that compiles. Wait, no, it doesn't. Expected type. Is this thing working? I feel like it's not even working. Yeah, list found hold A, list MA. So that should compile. No, it shouldn't. Oh, we need to do something with F. Probably like this. Why is this not working? I don't understand. Save. Still thinks that this is a hole. I don't understand. But okay. Alright, so it's a list of MB. What's the type here? This is an MA. So we need to draw from it. Right? Yeah. We need to create monad of B. Let's work our way down. Let's leave this like this. We're gonna do something with that for sure. So this is list MA. So list MA. But we need applicative M for that to work. All right, for this one, we have we're gonna have listed. By the way, it does say later here to implement these things. So this is really exercise 10.2. Right functor applicative. Listed. So that's what we're doing, by the way. All right, so this is a list of MB, and this is a list of MA. So if M is also a functor, we can just do fmap f fmap access. That's equivalent, by the way, to fmap.fmapf, which I tend to write a lot, actually, because I kind of like it. fmap, like this. Those are the same thing. Yeah. HLint sometimes will tell you to do it the other way. But basically, we're just trying to get through both layers of XS, right? So if we look at XS, it's just layer, layer. And as long as this M is also a functor, we can get through both layers and modify an A to a B. Okay. So this one, we got basically need to go get our Fs. So, but if we can, we need some partial function to extract this out. So I think we're gonna basically fmap applicative over this thing, and then this should be list of, oops, yeah, list of MA. So basically, we have two lists though. We have two lists. Okay, so why? Okay, whatever. Need to create a listed, and that's going to be list of MB. We need to fmap applicative onto fab, and then fmap that with XS. And this is going to be think in parentheses. Do. Why is this like this? There we go. I don't understand why writing is not updating, but whatever. All right. So let's look at this type again. Actually, let's do the following. All right. Interesting. Right. So this really probably needs to be a star. And for whatever reason, this is not playing nice, so we'll just leave it closed for now. So what if we... What if we do this and then just put that there? Let's do this with... See if we can do this with a list comprehension. So what we need is an F. Well, it's really... And we need an X from XS. And then what we can do is we can just say MF. So this is a lot easier to write this way. But what does this translate to in applicative? That's the hard part. Basically, the question I'm trying to figure out here is how do I write this in such a way that oh, yeah, okay. So, hang on. All right, so if I F map, that gives me a list. Oh, you know what I can do? I know what I can do. Where f equals f map right. So the point is I want to see what the type of f is. Really? It's a list of monad of A to monad of B. And what is this? The list of monad of A. So don't I just want to take F and F map that on XS? Oh, right. I still need to draw from them because they're in the list. So isn't that what I had before? Maybe it wasn't type checking before. So I need the apply because they're in the list already. So this should be fmap fab redundant. Oh, right. I guess I don't need that. And we can just put that there. I thought I had this before, but apparently I didn't. Not sure why. Is this easier to read? Yeah, maybe, but you know, you can just look at the types and it makes sense. We've written weird code like this before as well. Okay, so last one. So here we have list MA. So by using do, we're accessing the outer list monad. And F. So what is this again? An M of A. So we just need an A. Okay, so oh, right. So let A equal. Wait, what? Ow. Oh, right. That's just putting it back in. That's not going to help me. So this gives me the monad of A, and my F does what again? Takes an A. mean, there's no point in, well, maybe there is. Let me look at this again. I don't like calling this X, but whatever. Y map M unlisted dot F X pure concat Y. That's the well, let's just do this and see what the types are. Could not deduce traversable M from use of map M. Okay, so we would need a traversable instance of this as well. What's going on, 3 viewers? How is everyone doing today? Very quiet today. So we need to do this without traverse, basically. I mean, we could just implement traverse, I guess. Traversable. I need foldable as well. Okay, let's not do that right now. So this is an... I really don't like doing this in do syntax. I'm not having fun with it. I need more help from said compiler. Right, so this is... yeah, so we're gonna have a monad of A. This is a list of monad of B. And F all right, so I need to take A and bind it so that I can get an A. Yeah? Can I just put a hole here? No. Okay, better. So there's like an outer list thing missing here. So I need an A to MB, right? A to, and then we're gonna say unlisted dot F A, think. So if we apply FA here, this needs to be a monad of B, or well, an M of B. So if we take FA and we unlisted it, this would give us a list. So we just need to bind identity. Isn't that sequence? No. Hang on. No, that can't possibly be right. So this thing needs to be an M of B. So this gives me a list of MB. Gosh, I'm confused. All right, let's do the following. Put a hole here. And then say whatever, doesn't matter. Unlisted dot F A. Let's do it like this. I assume that we needed unlisted dot F. So what's the type app? So that's our F. And we need a foldable, which is XS. So this is our... I mean, this is what we need. It's literally just traverse. Okay, fine. Let's see if we can get those figured out. Instance, foldable, listed, and where? We need fold map or fold R. It's probably like this. What is this? Ooh, M. So fold R will be F. Oops. So F ACK. Yeah. And this gives me ABB. This is a B. And this is a list. And what's the result? M. What? Uh, right, we need to form a monoid. So if we're gonna do this, I don't think we can do that. I think we have to be fold R, F ACK. No, no, that's not right. This is making a B. I don't know that this needs to be foldable either. We got an ABB, and this, which is a I need a function that takes an MA. Don't I need sequence to implement this function, which is part of traversable? Very confused right now. Hang on, I need to use the bathroom. I really should make another scene that's like for need to use the bathroom, but best I can do for now. I'll be right back. I'm very much confused of how we're going to implement this function. Wait, no, it's not that complicated. Is it? I'm having a hard time with this, if that's not clear. Right. Oh, list. We need to be in the list monad. So okay, so if I put an A here, just to get other things to fail, this is fail. So this can't just be a monad, it needs to be a traversable as well. Because it needs to use sequence. And as long as it can use sequence, then it should be able to just concat Y, I guess. What's the type of MMB? So if we concat those, we end up with an MB, right? So let C equals concat Y. Why is this complaining? I don't understand. Is it M? What's up, BFG? How's it going? Oh, this is join. So we want to like let whatever equals join Y. And that comes from control monad. And then this should be what type? A monad of B, so we can just do pure A. Right. Okay, we got it. Join Y. All right, I'm doing well. We're sort of struggling through some of the last exercises of Book of Monads for chapter 10. But it's mostly because the implementations in the book were incorrect, so I had to quote unquote fix them. And me fixing them meant I needed to understand how they worked. So that's kind of where we were for the last little bit. The last exercise for this chapter was basically implementing functor and applicative for this monad instance. And they provided the monad instance in the book, but it doesn't work because well, maybe I'm using the wrong concat, but I think that they have concat in the book and it should be join, because this y right here is essentially a MMB, right? So I need to fuse these outer m's, and the only way to do that is join, not concat. Concat would work for lists, but we don't have an actual list right now. We have, you know, this anyway. Does that make sense? Hopefully. But it took me a little while to figure this out, because you have to play little tricks to get the types that you need to figure the solution out. So I'm kind of learning those little tricks in the editor to like get the types printed that I want. But it's basically hole-driven development, more or less, as usual. But it's kind of interesting, like if you put a return here, for example, this whole thing fails, and it's kind of hard to sometimes figure out why, and like the error is really difficult to figure out. So like if you put a hole here, it actually errors somewhere else, and then you can kind of work your way around to figure it out. So anyway, that's what we were doing. And the other thing is, to use mapm, you need traversable. So, because mapm requires basically a sequence operation. It's pretty fun, actually. I like trying to figure this stuff out. And we also figured out, we were stuck last time on this swap reader function, but I figured that out as well. So I was pretty happy about that. Those are the two things we've accomplished thus far. All right. So however, it turns out that this is not a lawful monad. So let's see that in action. Apparently the simplest way to do it is to do the following. So we're going to write a function called v, which is going to be int to listed int v of 0 equals listed 0, 1, v of 1 equals listed 0, 1. Okay. There's our v. And then we're going to just do the following. V. I hope these are actually implemented. V. V. $0. And I should put these in parentheses just to save myself time. Okay, so I need to go get that function, which comes from control monad. Okay, so it should be able to figure that. Oh, but right. I'm not in an editor, so I can't just use that. All right. Lib. Need to, sorry, this is way too big. I just need a show instance. Oh, but it's gotten rid of my V. Ugh. I don't know if there's a reverse search in here. That would probably be helpful, but I don't know how to use this that well. So I'll be terrible at it for now, I guess. And okay, so there we go. So there's one, and this should also work. It should produce the same thing. And you can see that it doesn't. So we have this element, which is the same, but then this element is swapped with some other ones. So these don't compose. So this violates the monad law. So it's not a law. Listed is not a lawful monad, but either way, it's it looks like it's pretty tricky to implement. So I think that was kind of the point. It's like learning how to implement these tricky instances. Even though I think that it's wrong in the book, but I don't know if there's a errata. Actually, that's an interesting question. Book of Monads errata. Programming in Haskell. It's not an O'Reilly book. Maybe we should start one, because that seems like an error. But also, this could be one of those things where if I was using like the GHC that they used, it would work, and it just doesn't work because I'm using GHC 8 something. I'm not sure. I'm probably on 8.4.4, I guess. Excuse me. Okay, so that's actually the end of chapter 10. So let's go ahead and commit all this. And then we'll start chapter 11. 10. It's okay. Oh, shit. I hope that's not actually an issue. It's probably really problematic that that was on screen, isn't it? I don't actually know. Might have to just like delete this, or like export this video from Twitch and delete it immediately. That sucks. So don't watch that, please. That's kind of the issue with the key in general. But you still have to break my passwords, so. Although I think there's probably more to what's going on that meets the eye. Get up. We need. It's right there. Boop. Okay. That's that. So now we can check out master, get pull, get branch D chapter 10. And then do stack new chapter 11. This is called a, well, I'm just gonna write monad transformers. I'm gonna have to change the title as well. What was we installed something before, but I don't remember the keystroke to get it started. That's not what I wanted to do. Probably want to be in here. Config nvim init leader F. Okay, so leader F, and we want to open up this. Just gonna put stir in. And we're gonna open up this. It's just a fuzzy file finder. We don't need this. Okay. In here, not in here. Here. We're gonna need transformers, and we're probably gonna need MTL. Although I kind of want to try out this. There's a package at the end called like vapor or something. Something like, it's like MTL, except it's using some type level stuff. Ether, I think. Look it up. Ether. Show me code. We might play with this. Was it back to Fireball? Lurk away, my friend. We might want that. But actually, do we need these if we're saying ether explicitly? I'm not sure. Let's just leave them in there. And that's probably it for now. No, what meetup are you doing? I'm doing well. Just we're starting Monad Transformer, so I'm pretty excited about that. Is this C sharp? You're a C sharp guy, right? At work, anyway. I like and. Code and caffeine evaluates to true, obviously. There's actually like a Rust coffee meetup that happens every week. I kind of want to go to it, but I already go to a lot of stuff, and then also streaming keeps me pretty busy. So it's just hard to get all of this stuff done. Like, there's not enough time. It's just, oh, that's not what I wanted to do. I got distracted. Okay. Oh wait, no, I want to make sure. I did want to leave, I guess. I could have done it in the background, but all right, so stack YAML, extra depths. Okay. Excuse me. Let's try this. Okay. Wasn't Freeman doing something to make this easier for us? Did that ever happen? I haven't seen Freeman in a while. I'm not sure if he's even coding. Okay. Maybe we don't want to use ether. There we go. It just has a lot of dependencies. I don't know how I feel about that, but it should be fine. I don't know. Okay, we're not using ether because I don't want to figure out these. So stack build. Oh, package YAML 26G. This should build no problems. So maybe we'll stay away from ether. Although that does bring up an interesting opportunity to try and bring ether up to date. Let's see when the last change was made. Last year, basically. Are there any active? Well, when was it last committed to? I want to look at this. "2016. My goodness. So there are two dependencies on this that seemingly are problematic, I guess. It looks like these ones are the ones that are problematic. Not, sorry. Maybe this one and Transformers Lift. I don't know. It could be an interesting thing. I don't know if I could do it, but maybe. I don't really. I mean, I don't know what that error is. It's hard to say. It just kind of seems to fail. Yeah, it's like writer CPS MTL fails. Doesn't really tell you why though. So anyway, not my problem right now. Let's just start working. Okay, so we looked at this previously. So let me just put it back. Evaluator. Reader. Assignment. B. And I'm gonna need some stuff here. So this is gonna come from import control monad reader probably. And then we need, oh, and I need an A here. And then we need this assignment type, which is, I can't fuzzy find that one. Chapter 10 source eval. Is what? A string. So we're gonna need these types anyway. But I don't see the point in having a name. Put these here. Put these here. And I would really like to make this a new type. And as far as I'm concerned, this can just be a string. Not gonna help me at all. This can also just be a string. Okay, so ZT. And the same thing can happen here. So go. The way I like to do this is uneval tour. It's just the style that I haven't seen Newmate in a while, but I think that he is I think that he's lurking at times and he's just not talking. I think he's in school now, so he's just busy. I do miss him hanging out though. Oh, active. Well, yeah. Did I tell you on Saturday? Jappy and I are going to be doing a lens tutorial thing at 10 a.m. and we're going to go to 12 when you start, I believe, and then we're planning on rating you. So hopefully that will help you out a little bit. I don't know if it actually helps, but I'll try and hang out. Question mark? So you stream Saturdays at, well, noon Eastern, which is not the same time for you because I think you're West Coast. But the plan is to that's the plan, is to try and send people to you. Not that I ever have that many viewers, but might be interesting. Okay. It says, consider now a similar scenario in which the assignment is not only read, but also updated. We need a state monad instead of a reader. Oh, well. It's worth a try anyway. State. All right. So, consider that. This suggests a way to add failure to any other monad. Just change the return type to maybe. This is what we call the maybe T or option T. Well, I'm just going to use the Haskell term, maybe T monad transformer. So we will try. So I need the trans maybe, I think. Okay. Anyway. So we're gonna write. There's just some information here about like the key point is that if you had maybe T and the M was a monad, then maybe TM is also guaranteed to be a monad. So that's kind of the goal here. So we're gonna write exercise 11.1, rewrite eval from chapter 10 using maybe T. So eval going to be expr maybe T state assignment integer. All right, and then over here, I just want to go look at that again. Nope. Okay. So now we have a maybe T. So we're gonna have literal something like this. Let's just put a hole here. So n is an integer. So I think this means, wait, how do, oh, I see. So we're gonna need to return a state, which is an assignment integer, I guess. So given an S, something like this. Pure, need to go look at this state again. Do, 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 do. I need a put. put. Takes a state into the monad. Hmm. Oops. Okay, so let's see here. So if we write return A, what does that do for me? That's just an integer? That's it? Okay. I guess I was overthinking this. We need RV. I'm guessing this is the same, isn't it? Except it's the state version, which I think would be get or something. Get? Could match type. Turn. Does this compile? Need an assignment to an integer. What is lookup again? What is lookup? So it takes an A and that thing and returns a maybe. What's gets? It's a specific component of the state using a projection function. So that would take an assignment to int. Is this lookup v? Oh wait, no. It would be gets lookup v, I guess. Assignment. What is v? Just a string. So lookup so this gets the assignment, right? So if we get I thought that was right before. But this is not right. Assignment to integer. How's lookup work? I should have written the types down. Oops. Sorry, Google. I meant Google. It takes an A. But this returns. So lookup's not the right function. I guess. But it's probably has to use lookup. What if we do it like this? So we're gonna have assignment. Well, it's really assignment. I don't know. T for table. Get. Put a hole here. And what's T is our thing. So we'll let Cajunix. Thank you so much for the follow. Really appreciate that. Actually, also 3 days ago, which we weren't streaming then, but Smart Medical also followed. So I appreciate both of you. Thank you. Are you a fan of Haskell or just kind of stopping by, interested in me smashing my head against the wall? Because that's usually what we do. So this is going to be a maybe integer or something. It's a weird thing to write, but well, it's not that weird, I guess. Look up. Nope. It's a let binding. Look up v me. Expected type with actual type. What? What's the type of? Oh, with T. Here we go. I'm a fan of Haskell. Just got the book and found your channel. I have some catching up to do. Yeah, we have a lot of these videos up. So yeah, feel free to peruse. But we're chugging along. I mean, like if you like the book and you want to do it yourself, you should. You shouldn't use me as your solution for figuring this out, because the only way you're going to figure it out is writing it yourself. But I've solved, I think, every exercise in the book, so if you get stuck, you know where to look. There's also a GitHub page if you want to check that out. So you're welcome to steal my solutions if necessary. But I highly encourage you to try and do it yourself as much as you can. To be fair, I got a lot of help on this channel, so it's kind of unfair to say that. Yeah, to say that I did it myself as well. So okay, so what do we need here? We need to. We got a maybe here. That's a maybe integer. I got a maybe t. I need to go look at the state again. State t. No. Well, what's maybe t, I guess. Is there something that takes a maybe? Doesn't look like it. This is a pretty interesting function, but that's not going to help us, I don't think. State here. I think we need to. So our state is basically the integer. So we need to. Yeah, I definitely do. It's like, it's gonna be like pure, and then from maybe. Well, actually, what we can do is just guard. We can guard. I think we can do guard is just. Hang on. Me. So if we do guard is just me, I think that deals with the outer case, and then that way we can just do let just int and then we can say put wait, no, that's not right. So the state is the same. It's the integer that's changing. So don't I need to? I don't need to set the state. I need a new. I don't know what I need to do. I think we're going down the wrong road. Maybe. So this is like where I've gotten stuck with using Haskell generally speaking, is I really don't understand how to use these monad transformers. And like, I'm not sure that the book gave me a ton to work with for figuring this out. But Maybe it did, and I didn't get it. I think this is all wrong. I think I need to... What do I need to do? This can be pure. We're gonna need pure, then we need to do something. That gets us the maybe T. What I need to do is make the state. So this... Right, I can't... That's the thing I'm confused about, because I need to get an integer, but I don't have an assignment. So like I almost have this, but I've replaced... Right, the maybe is now on the outside. So I need to like... I don't even know. I don't know what I need to do. Like type shenanigans, I guess. Because this is the piece that can fail, right? The lookup can fail. The maybe is on the outside. Oh, right. This is the trick that things are not as they seem when you unpeel these things. Right? Because if I unpeel this, then it's... So is it so it's supposed to be this then? Uh understand. Integer. There's no functions in here. Am I supposed to use accept? Wait, no, that's either. What is... There's no functions here, I'm confused. Shouldn't there be... Constructor is the only function you need here. Takes an M of maybe A. Is that not the same as pure? It's not. It's interesting. So assignment to maybe, so we need to unassignment lookup v. Use gets. Okay, so it's supposed to be gets. Weird. I was under the impression that pure just gave me basically the maybe deconstructor, but that's actually not correct. So I think I was misunderstanding what's going on. Because this thing has this, you know, it's embedding this integer. Wait, no. This is this, yeah, that's an integer. Okay. Hard. Hey. What time is it? 9:30. Never fails. The cat always starts getting crazy around 9:30. Could you stop? Need to fix something. He likes to destroy the shades. That's going to cost me a ton of money when I need to move out of this apartment. That's not really that much money, but it's not zero money either. Alright, so what are our types here? We need to deal with op, and that's basically going to be outside. Let's can I just do you? Okay, so that just gives me two integers. So we can just do this is going to be so I think it's just going to be something. Why is this a maybe? Really? Nice. What is it? Subtract, multiply, divide. Couldn't match type. How do we fail? I always like writing pure nothing. It's like a funny thing to write, I feel like. Man, this is actually pretty awesome. I find this really tricky right now, but like, um, yeah, like because this pure isn't working, um, in the outer position because you're it's embedding like an entire state t, uh, assignment maybe integer, but well, you want to build a state maybe integer, so you need a pure nothing and then wrap that in a maybe t. Hmm. Okay. Is it? It's just empty. Is it supposed to be empty? Well, that's no, that can't be right. Uh, Empty probably comes from control monad or something. Where's empty come from? See if I can find it. Empty. This one. Alternative? So duplicative? Duplicative. Empty. Neat. That's pretty clean. This one is trickier than this one, but oh, that's true. Uh, like do guard. Oh, and then this. I always do this. It's this. You just have to flip the if, right? Because you want to guard for. Wait. Guard triggers when that's true? And I used it earlier, didn't I? Wrong way. I did use this earlier, but I don't remember. Yeah, so false yields empty. Yeah, so not equals. I was right the first time. Why can't I click? Yep. That's a little tricky, but only because I I don't use guard that often. Right, you want that to evaluate to true, such that it gets pure void, not void, unit, and then that way you can continue. So if as long as this is not empty, i.e. false, yeah. Wait. Yeah. If it's false, you want it to fail. So equal 0 gives you false, therefore it will fail. Okay, got it. How does this compare to this solution? I'm into hit control. Yeah, this looks worse. Actually, we have cleaned this up a little bit, as it turns out. So it's kind of neat. This is obviously a little trickier, but there's a lot less code in the other piece, so that's kind of nice. All right, so we did that. That was kind of hard. All right, so it says, remember, most monads come with an associated run monad function that executes computation. Excuse me. So basically, you need to run maybe t first to strip off this. So like, let me say this. So to get the integer, need to so it's going to be like result so first you need to run maybe t of like expr of e. Then you also need to run state and then you need to give it an assignment. So this is going to be like a I don't really want to a to reduce it, so it's gonna be like this. And it's really just this, isn't it? All right, so essentially what this is saying is I'm going to pass an expr and an assignment. Although this shouldn't work, should it? Because this eval is expecting, well, I mean, clearly it composes together correctly. We put this here, what do we get? Yeah, it's a little complicated, but even if you put e here, wait, this doesn't work? Oh, right, I need to apply this whole thing here. That feels incorrect. What if we just use a ton of dollar signs? Right. So you need to do this first. You need to do this whole thing first. Huh. That's kind of wild. Interestingly enough, it doesn't say to A to reduce this. What if you put this here? I don't know. I don't know what's more readable. Probably this, though. Okay. Anyway. So this is kind of the thing. You have to peel the outer layer off first. And then you can peel the inner layer off. Um, okay. It says almost every monad has an associated monad transformer. Most of them are defined in the transformers library. It says our description of resource management monads in chapter 9 left types conspicuously absent. Here's the reason. Since using those monads only makes sense when working with a larger monad with resources to manage, the corresponding libraries only provide transformer versions. As an example, an operation that returns the contents of a file is assigned the type resource TIO string. Alright, so it says write the monad instances for the combinators of the above transformers with an arbitrary monad. For all of them? I don't want to do all of them, but I guess I can try. Or is it only for... What transformer? Above. The arbitrary thing to say. Is that all of the ones from... of the above? Or is it supposed to be resource T? No, that just makes sense. See, as we've done. Okay, so sure. Aren't these already written though? We'll start with the oh no, it's is there a way to write duplicates? Otherwise I have to write the whole thing. I mean, I guess I can just write the whole thing, right? Not sure that I want to, but this this is not a thing. All right, so basically what we'll do is just plug in the functor instances and like all the instances, but we'll just ignore, like we won't implement them. Although we probably should. Okay, and what we should do is create a like a snippet for this. I don't know how to add custom snippets in CSC and Vim, but I should look it up. Sorry, my back is really, really sore. Oh. Okay. Let's do it, I guess. We might not need that, but we'll get there. Oh, wait, let's get rid of that. Probably. But I'm gonna leave it off to see what we need, and we'll add it as we go, I guess. Also, hey, Pick, how's it going? I feel like we've had a pretty productive stream thus far. So, what's the type of this? It definitely needs to be a functor. At least. It probably needs to be those things all the way down, but we'll deal with those when we get there. So this is just an A to B. Nope. This is an M, maybe A. And we need an M, maybe B. So it should just be fmap, fmap, in a maybe T. Okay. Or you can write fmap, like fmap dot fmap in parentheses, fm. Doesn't matter. Either way it works. So this is gonna be an A. And we need maybe T pure A. Oh. Right, so this pure makes it a just. This pure makes it a whatever the monad is, and then you stick it in a monad T. So if we look at the D here, you'll see we get a maybe A and we produce a new M. So that's why this needs to be applicative, because we need to be able to pure. So here we're gonna have maybe TF, maybe TA, and this is a and this should be a all right. So basically we have a similar situation to what we had before, you need to fmap an apply function. Oops. Yeah. So we're gonna need to like fmap. It's gonna be like maybe t should be like this. I've seen that pattern so many times now. Like it's just pretty natural to write that. You just have to recognize that this pattern is like I don't know how else to explain it. When you see this pattern enough, this is like some monad embedded in another monad with or well, a monad of an f, right? And this thing is what you want to make an applicative. So what we're doing is partially applying the applicative to this and then applying it to our a function via applicative. So it's, I don't know. Once you see the pattern a few times, I think it becomes pretty natural to write that. But if you've never seen that pattern, I apologize, because that's probably very tricky. Mainly because you're probably also not familiar with all of these symbols, because there's a lot of symbols in Haskell. So again, sorry. I don't know what else to tell you. There's not much I can do. Okay. So we got this. We're probably gonna have to bind it. And we got that. So we're probably gonna have to run at some point. So it's probably gonna be like maybe T. A. Okay, and our A here is a maybe A, and our F is going to right. We're basically gonna what are we gonna do? So we have a maybe A and an A. So if we fmap this, that's not what we want. We need a bind. So really, so if we bind here, can we do that? No, I didn't think so. So run maybe TF. Oh wait, I can't do that. I need to apply F to something. Um, I guess this would be easier to do with do syntax because I can use guard again. Right? If I do A M A Oh, yeah, okay. Fine. Like so. Okay. We could have done the following, by the way. And I actually probably think this might look better. Maybe. Seriously, it says stupid. Lambda case is great. I really like lambda case. Makes a lot of this stuff a little clearer, I think. The hell? All right, so it's 10:20, and I'm supposed to do this for accept T, state T, reader T, and writer T, I suppose. Potentially cont T as well. Gosh, it's going to be exhausting, but I feel like it's probably a good exercise. Except that we don't have time to do it.